this video, we will be formally defining unknowns and then creating a system of linear equations to solve for the unknowns. To solve for the unknowns, we are going to need to create the same number of equations as unknowns. We will be solving the systems of linear equations by methods discussed earlier in this chapter. Now, most students go wrong when they do not have every term within an equation with the same meaning. It is very, very important that you understand the following, and that is, first, you need to make sure that every term within an equation must have the same meaning. The equations themselves that make up the system can have an overall different meaning. Let's go on to our first problem. The Forest Theater can seat a total of 360 people. They take in $15,150 when every seat is sold. If orchestra tickets cost $45 and those in the balcony cost $35, find the number of seats in the orchestra and in the balcony section. Generally, the last part of the problem can help you identify the unknowns. So go there if you're having a problem with that. There are two unknowns, so we will need to come up with two equations, two facts, to solve for the unknowns. Here's my organization for this problem. I've put the unknowns at the top of the columns and the two different pieces of information or facts going along the rows. This organization will directly help us write the equations. And recall, we need two equations to solve for unknowns. We have two rows of different information to build these equations. Now notice how every term in the first equation means number of seats. The second equation, every term gives us a value. Now I chose to reduce the second equation as my first step. There's a common factor of 5. And from there, I went with substitution. Remember, it's your choice as to how you want to solve. Work through the following steps to verify the process, or work the problem again using the elimination method. When you're done, verify the solutions by substituting back into the original equation. Double check to see if the total of the seats is 360 and the total value is $15,150. If so, you do have the solutions to this word problem. Here's our second problem. Find the amount of 6% acid solution and the amount of 14% acid solution a lab assistant should combine to prepare 50 cc's of a 12% solution. Now, somehow we need to organize the information in the problem. First of all, how many unknowns? This is a mixture problem. I prefer getting organized with the box system as seen earlier, back in chapter 2. First equation adds the separate volumes together for the total. The second takes concentration and multiplies it by the volume for the amount of solution that is acid. On this side, I start by multiplying all terms of the second equation by 100. This is done to clear decimals. Then I went on to reduce that equation. I decided to go with the elimination method. So you can see I'm multiplying the first equation by -3 and then adding it to the second equation. So back to the problem. We were to find the amount of 6% acid solution and the amount of 14% acid solution a lab assistant should combine to prepare 50 cc's of a 12% solution. And we found that the lab assistant needs 12.5 cc's of the 6% and 37.5 cc's of the 14%. Here's our third problem. The sum of three numbers is 295. One number is 5 more than the second and twice the third. Find the numbers. Now read the problem enough times so that you can find the equations necessary to solve for these three unknowns. Let's start by defining our unknowns. We need to pick apart the problem to create the system of three equations to solve for those three unknowns. And here's our system. Let's figure out the best way to solve. Look at the second and the third equation. If you were to solve the second equation for y and the third for z, they would both be in terms of x. And then these could be substituted into that first equation to get it in terms of x. So here we go on to do that. And if you look along the bottom there, we're ready to solve that first equation that you've substituted in for. You're ready to solve for x. And we find the first number is 120. Working backwards using substitution, we can find the other two numbers. So our three numbers are 120, 115, and 60, and they do add up to 295. And here's our fourth problem. The perimeter of a triangle is 126 units. The length of one side is twice the length of the shortest side. The length of the third side is 14 more than the length of the shortest side. Find the length of the sides of the triangles. How many sides are there in a triangle? 3, therefore we have 3 unknowns. Reading the problem more than once if necessary, we notice that the other two sides are stated in terms of the shortest side. Therefore, it's very important that one of the unknowns be stated as the shortest side. So here we go. Let's define those unknowns and then go back and break up the problem so that you can find your 3 equations. Here the substitution is fairly straightforward. We don't need to rearrange the equations, just substitute directly into that first equation. With x, the shortest side, equal to 28, we can now work backwards to find the other two sides. Performing the check, again, do all sides add up to 126? They do, so we formally state the result. Thank you for listening.